Hi. Okay, so this lesson is number 4 in the integer unit. And the title of this lesson is called Tricks to Efficiently Add Integers. And below I wrote without the number line. We're going to have situations where adding on the number line is not going to be convenient because the numbers may be really small or really large. So the purpose of this lesson is to figure out how we can add these integers without the number line. I start out with an opening exercise, and I would like you to pause the video and try the opening exercise on page 13 on your own. So I'll give you a moment to try this out, and then I'm going to go over this in just a moment. All right, you may begin. Okay, so hopefully at this point you've worked on the opening exercise. So on the next page I can show you my answer key. Okay, so we'll start with question A. It says represent the sum of 3 plus 5 using arrows on the number line. This type of problem, ordinarily you wouldn't use the number line. 3 plus 5 is 8. We can do that even with our fingers. But the reason why we had us demonstrate this is because our arrows, and we talked about this in the last lesson, our arrows are going to the right because we're adding two positive numbers. So the valuable lesson to learn from this question is that anytime you add a positive number, you're going farther and farther to the right on the number line. So that helps us answer question B. So let's take a look at my response here. Question B asks, do you think that adding two positive numbers will always give you a greater positive number? Why? So our answer is yes. If you go farther and farther to the right on the number line, and again, anytime you add a positive number, you are moving to the right on the number line. So yes, the sum of two positive numbers will always be positive, because the farther to the right the arrows are drawn, the larger the number. And the larger the number, that also means that it's going to be a positive number. Okay, so question C goes in a slightly different direction. It says represent the sum of -3 plus -5 using arrows. So our final answer is -8. And the point that we want to make here is that anytime you add a negative number, so in this case we started with -3 and then we added -5, we're going to the left, right? Our arrows are pointing to the left because both of those numbers are negative. So similarly with question D, now they're asking, do you think that adding two negative numbers will always give you a smaller negative number? Smaller definitely is true, and this is sort of a misunderstanding when we look at the number line, but believe it or not, the farther to the left we go on the number line, the smaller your number will get. Okay, so that is a true statement. So again, our answer to question D is yes. The sum of two negative numbers will always be negative, and furthermore, the farther left the vectors are drawn, or in other words, instead of saying vectors, you could also say arrows. The farther to the left the arrows are drawn, the smaller the number. All right, so now let's take a look at the next page in our notes. So we have exercise 1 here. Once again, I would like you to pause the video and attempt this on your own, and I'll go over the answers once you've finished that. So pause and you may begin. Okay, hopefully you've had some time to go over exercise 1 and thoughtfully answer those questions on your own. So now I'd like to go over that, and I've already filled in the answers here. So in exercise 1, they're only asking for you to decide if your final answer is going to be positive or negative. So anytime you add a negative number, your final answer is going to be negative. And anytime you add two positive numbers, your answer is always going to be positive. Again, going back to the observations that we made in the opening exercise on the other page, just further practicing that skill. All right, now example 1, we're going to transition to a different type of problem. So in question A, it asks, represent the sum 5 plus -3 using arrows on the number line. And again, I know that we're using the number line to start out, but we're hoping that we can learn something from this so that we don't have to use the number line for future problems. Now, what makes this question different than our opening exercise is we have a positive number and we have a negative number that's being added. Positive 5 plus -3. So now we're going to focus on what happens when the numbers do not have the same sign. And when I say same sign, I'm referring to if the number's positive or negative. Okay, so let's start by just representing this on the number line. Positive 5 means I'm going to the right 5 spaces. And when I'm adding -3, I'm going to pick up where I left off and draw an arrow that is 3 spaces to the left. Okay, so that means that I'm going to stop at positive 2. Okay, so in conclusion, that means that if I add 5 plus -3, -3, my final answer is going to be positive 2. All right, so using the number line to answer some questions, question B now asks, which arrow is longer, how much longer? Okay, so we're going to make this short and sweet. We can see that the blue arrow, and I'll highlight that, the 5 arrow is definitely longer than our orange arrow, right? So, and it asks by how much. So we'll say the 5 arrow, the arrow that represents the integer 5, is longer than the -3 arrow by 2 units. So there was a reason why they asked that question, all right? And I will come back to that once I've answered question C, but there is a purpose for why they asked which arrow is longer. How much longer is it? So, but let's answer question C first, and then we'll go back to that. Okay, so question C asks, what is the sum? If you were to represent the sum using an arrow, how long would the arrow be and what direction would it point? So we know already that the final sum is 2. When we added 5 plus -3, the final sum was 2. So let's write that down. The sum is 2. The sum could be represented by drawing, oh, I forgot the R, drawing an arrow 2 units to the right. Okay, so I want to make a comparison when we look at the question and our answers to question B and question C, because those two things are related. So let's first start with which arrow is longer. What would be the reason why they would ask that? Well, the 5 arrow is longer, which we've already said, and because of that, that number is positive, positive 5. We went 5 spaces to the right. We only went 3 spaces to the left because -3 is a negative number. So because we went farther to the right, that number with the longer arrow was positive, our final answer ended up being positive. And again, let's go back to our answer here. So the final answer was positive 2. So question B, which arrow is longer? This first question helps us decide, is this going to be a positive answer or a negative answer? And in this case, it's positive. Okay, so the second part of this question was, how much longer was that arrow? So let me highlight that in pink. We know that it's longer than the -3 arrow by 2 units. Well, 2 happens to be our answer. So you need to figure out the difference in the lengths to figure out what the actual number is in your sum. So that 2 that I've highlighted in pink, the 2 as our final answer, that came from the fact that our arrows had a difference of 2 units. Okay? So both of those questions are going to have to be considered when you are trying to add integers that have different signs when you're not using the number line. So what I mean by that is if I asked you to add 10 plus negative 1,680, that would be a silly question to add on the number line because you would be counting 1,680 spaces to the left on your number line. That's a lot of spaces. It would take you a long time. All right, so instead of doing that, what you could do is imagine, don't draw it, but imagine if you were to draw this, which arrow would be longer? Okay, in this case, because our negative number would have a longer arrow, that's a negative number. So in that case, if we were to add 10 and negative 1,680, I know that my final answer is going to be a negative answer. All right. And then the question is, well, how much longer is it? Because that's going to help me decide what the actual number is in my final answer. All right. So again, answering what the difference is. Well, the first arrow, 10, positive 10, that's 10 spaces long. Whereas the other arrow, negative 1,680, that's it's 1,680 spaces long, right? Distance is positive, so I didn't mean to say negative. So the difference, all you'd have to do is subtract them. So 1,680 minus 10, right? That's going to give you 1,670. All you had to do was subtract. So your final answer would be negative 1,670. So that's a more extreme example, but I wanted to show you how that thought process could be represented in another problem. All right, now let's take a look at example 2. So it says, represent the sum 4 plus negative 7. Very similar situation. So we're going to do this on the number line. So let's start with 4. So I'll go 4 steps to the right, or 4 spaces to the right, and then I will go 7 steps to the left. So 1, 2, 3, 4, 5, 6, 7. So this is where I'll stop at negative 3. And okay, so in conclusion, according to our number line, 4 plus negative 7 gives us negative 3. So we're going to answer the same questions that were presented in example 1. So it says, which arrow is longer? How much longer? Okay, so we know that in this case the purple arrow is longer. So we'll say the negative 7 arrow is longer than the 4 arrow. And let's think about that. They want to know what the difference is. Well, the negative 7 arrow is 7 spaces long. The 4 arrow is 4 spaces long. So when you take the difference, when you're finding out how much longer one is than the other, you have to subtract, right? 7 minus 4, the difference between those lengths is 7 minus 4. That's 3 units. Okay, so the negative 7 arrow is longer than the 4 arrow by 3 units. And that's our final answer. Okay, so in question C, it asks, what is the sum? If you were to represent the sum using an arrow, how long would the arrow be and in what direction would it point? So we know that the sum is negative 3. We already answered that when we drew our vectors on the number line. So the sum is negative 3. And we could write the sum could be represented by drawing, could be represented as a vector drawn 3 units to the left. So once again, the important question to ask when you're trying to figure out this type of problem without the number line is right here. So these are the magical questions that you need to answer. So look back at question B. Anytime you try to add integers that have different signs, meaning one positive number and one negative number, the trick to it is figure out which arrow would be longer. Okay, even if you don't have to draw it to figure that out, which arrow would be longer and by how much. So you have to subtract the lengths of the arrows to figure that out, to figure out how much longer one arrow is than another. Okay, so I have an exercise down below that asks for you to determine what sum will be positive and negative, and you have to decide based on which arrow would be longer, or in other words, which vector would be longer if you were to use the number line. So I would like you to pause the video and answer exercise 2 on your own, and then we'll go over that in just a moment. So you can begin. Hopefully you've had an opportunity to answer exercise 2 on your own, so I can go over those solutions now. So let's take a look at exercise 2 here. So there were 2 parts to this question. It asked for you to circle the integer with the longer vector. So that's what I've done. And then from there, whatever that sign is, that's going to determine if your answer is going to be a positive or a negative sum. So for question A, your sum is positive. Question B, your sum is negative. Question C, your answer is negative. Question D, the sum is negative. Question E, positive sum. And question F, negative sum. Okay, so now we're going to formalize these tricks. We've made a lot of really good observations, and now we want to use that in formal rules for adding integers without the number line. So there's 2 rules, and it's on the next page. So if you haven't already flip to the next page in your notes. So integer rule number 1. This is when you add integers that have the same sign. So when I talk about the same sign, that means that either both of the numbers are positive or both of the numbers that you're adding are negative. All right, so that's what they mean by adding numbers with the same sign. When that happens, the directions state add the absolute values and use the common sign, which that sounds a little bit more complicated than it needs to be. So I'd actually like to take a look at exercise 3. I'm going to go over rule number 2 in the next exercise, so we're going to hold off on that for the time being. And again, my reason for that is because exercise 3 only uses rule number 1. So let me demonstrate what they're talking about here. So first of all, in the directions, it says use the integer addition rule to find the following sums. So this time we are going to figure out what the actual sum is, what the answer is once we've added. And it does say use a calculator to check your answers. Because we're new and we're trying to figure out these rules, I strongly encourage you to use technology to just double check and make sure that you've done the right thing. So basically, what they're saying is, in rule number 1, if the numbers have the same sign, that means that we're adding 2 negative numbers or 2 positive numbers, add the absolute values. Okay, so one thing that I like to do to organize my thoughts is I'll make a chart. I'll have a negative symbol on the left side and a positive symbol on the right side. So I'll set it up like that, and then I can organize all my negative numbers on the left side of my table and my positive numbers on the right side. Because we're using rule number 1, I'm going to have numbers all on the same side no matter what. So in question A, I have two numbers with the same sign, -1 plus -7. So I'm going to list those two numbers vertically, and I'm going to do that so then I can actually add those two numbers. So then in the directions it says, if I go back to my rule, it says, first of all, rule number 1, same sign, check, that's done. Then it says add the absolute values using the common sign. So what they mean by that is to get your actual answer, all you have to do is add the absolute values. Well, the absolute value of -1 is 1. And we've talked about that symbol, but I'll just make a note over here. The absolute value of -1 is 1. The absolute value of -7 is 7. So they said add the absolute values. Well, 1 plus 7 is 8. And then it says use the common sign. Remember, anytime you add two negative numbers, your answer will always be negative. So that's why I like to draw this little chart as a visual to say like, hey, all of these numbers are negative, so my final answer is going to be negative as well. So my final answer is going to be -8. And I did demonstrate that question A for you, even though it's an exercise. I do want you to try the rest of the exercise 3, on your own. So pause the video, and then once you're finished, you can push play. So get started with that. So hopefully you have finished exercise 3 and used the calculator to check your answers. So now I'm going to go over those solutions. So let's take a look. So I did include the work so that you could see what I did on my paper to represent each of these sums. I'm just going to make a little note here with question D and with question F. I'm going to circle those. You're adding two positive numbers, 5 plus 4. You do not need to overthink this. You don't need to make a chart for this. 5 plus 4 is something that you know just by counting with your fingers or mental math. So I didn't show my work for question D, and I did not show my work for question F. 2 plus 7 is something that you guys can do very simply. So don't overcomplicate these problems. And when you are done checking over your answers, let's move on to the next page. If you need a little bit more time, just pause the video. And if not, let's move on. So now we're going to hone in on rule number 2. So let's read that together. Rule number 2 is a different type of problem. Okay, this time when we add integers, they're going to have opposite signs, or in other words, different signs. So in this scenario, we are going to have one positive number and one negative number. So that's what they mean by adding integers that have opposite signs. So when we have a scenario like that, we are going to subtract the absolute values and use the sign of the integer with the larger absolute value. Or in other words, because we did talk about this concept, when they say larger absolute value, they're basically saying the number with the longer arrow. That's what it would have looked like if we were on the number line. So the final answer will be positive if your arrow, the longer arrow, is positive. If your longer arrow is a negative number, then your final answer will be negative. Okay, so with that said, I am going to very briefly demonstrate. I'll do exercise 4A just to get you started. So I'll start with the directions. It says use the integer addition rule number 2. So we're only focusing on rule number 2 for these problems. To find the following sums, it does say to use a calculator to check your answers when you're done. So try this on your own first. Try to add these without a calculator, and then once you're done, use the calculator to check your work. Okay, so I'm just going to model A to give you a taste of what I did on my paper. So I started with the T-chart. So I have the negative and positive symbol there. And this time I'm going to have numbers on both sides of the table. So I have -6 here, and I have positive 4 over here. So in the directions, they said, okay, well, if the numbers have different signs, if one number is positive and one number is negative, you need to subtract the absolute values. So we'll just make a note, the absolute value of negative 6 is 6. Okay, and the absolute value of 4 is 4. So they said you need to subtract, you need to figure out what's the difference between the lengths of the arrows. So what is 6 minus 4? So the answer is 2. But we're not done yet because we have to use the arrow that's the longer, that would be longer on the number line, or in other words, the larger absolute value is going to determine if your final answer is positive or negative. So we need to go back over to our table. All right, so this arrow here is negative 6, so that would be 6 spaces long. Okay, and then over here we have an arrow that's 4 spaces long. So the larger absolute value, or in other words, the longer arrow, is going to be negative 6. So what that means is I'm going to have a negative answer. So my final answer is going to be negative 2. So it's a combination of look at the longer arrow and then subtract. So there's 2 steps to this. It's not quite as simple as the rule that we just used, rule number 1. All right, try exercise 4 on your own. So pause the video, and once you're ready, you can push play and check your answers with me. Okay, so if you're ready to check your answers, I'm going to flip the page to go over my solution and my work. So for exercise 4, here are my answers. I just wanted to point out that I don't show the absolute value for every problem. I did for question A just to make a point. So you'll notice over here I wrote the absolute value of negative 6 is 6. The absolute value of positive 4 is equal to 4. That's something that you can do in your head, so it's okay for you to not show that step in your work. The other pieces to the work that I've shown, such as making the T-chart that I've highlighted in green, doing this, I think, can be helpful as a nice little visual, so that way you can compare the positive and the negative number, but it's not something that's mandatory. Some people like showing their work and having that visual, and some people are able to do that math in their head. So that's sort of your personality. But the important thing that you get out of these exercises is, once again, the steps, the process. So with rule number 2, the first thing you need to do is decide, is my answer going to be positive or negative? Decide which number has the larger absolute value. Another way of asking that same question is, which number has the longer arrow on the number line? So that decides if your answer is positive or negative. And then once you've done that, then you can subtract the absolute values. So in this case, for question A, we subtracted 6 minus 4. So our final answer for A is negative 2. We've already gone over that one. So question B, the answer is 3. Question C, the answer is negative 6. Question D, the answer is 1. Question E, the answer is negative 7. And question F, the final answer is 4. So if you need more time, pause the video and observe the work, and certainly ask me questions if there's something that you would like a better explanation of. So now let's take a look at exercise 5. You'll notice that in the directions it says decide which integer addition rule must be used to find the following sums. So exercise 5 is a summary of everything that we've discussed in this lesson. I'm not going to go over that, so that's something that you need to do on your own. And you also have a calculator to check your answers. That concludes this video. I hope that you found this helpful. And again, if there's anything that needs to be clarified, there are so many other ways that I can go through and explain things. So don't be afraid to reach out. All right, thanks for watching, and Have a good rest of your day.